Okay, perfect. So there are 3 parts of this quiz that we did Wednesday. The first one is review. So we have determine equilibrium shift when stress is put on a system. And then these ones we talked about Wednesday, and that I'll talk you through right now if we have time. If not, I'll film a second video and then you can watch the video. So if we're looking at page 29, I know that you've already done example 3 and example 4, but just look at those examples as I talk through this. So if we have, and I'll have this written on the board when you do your retake, and if it's not there, remind me and I'll write it on your paper. If reactants turn into products, okay? So if reactants turn into products, this is a forward reaction. And as a result of that forward reaction where reactants turn into products, reactants decrease and products increase. Okay? Reverse reaction is the opposite of that. It's when we have products that turn back into reactants. Okay, so we made some products, but then they went back and they turned back into a reactant. That is the reverse reaction. Okay, so that's our reverse reaction. When this occurs, products decrease and reactants increase. Okay. Now, when we have a reaction and it's got the double arrows, that means it can go back and forth. And it's going to be at equilibrium unless we do something to throw it off of that equilibrium, and that's what the stress is. So above the reaction is always where I write the stress. Like any arrows up here indicate something that I've done to the reaction to throw it out of equilibrium. And then all the arrows that I draw down below, that is the response by the reaction. Okay? So in this one, it says, what would happen if you remove some CO2? That is the stress. Like this reaction was all happy and at equilibrium, and then I come in and I remove some CO2. So the stress is decreasing the amount of CO2. Okay? If something is taken away from you and that stresses you out, if you get your phone taken away and that stresses you out, do you then choose to take away your laptop? Probably not, right? You probably try to do what you can to get your phone back. And guess what? Reactions do the same thing. If something is removed from them, then they respond by trying to make more of the thing that was removed. The response is always the opposite to what the stress is. At this point, after you have figured out the response by the reaction, then I want you to ignore the stress. Okay? Like after we have figured out what the stress is and how the reaction responds, then I want you to ignore that stress. I'm only focusing on how the reaction responds. So here are our reactants to the left and here's our products to the right. And the reaction is trying to increase a reactant. Okay, people in the classroom, which one is that going to be? Is that going to be a forward or a reverse reaction if it's increasing a reactant?
Reverse.
Good, that's going to be a reverse. So the reaction is going to favor the reverse. Okay, so we're going to favor the reverse. Okay, and a result of favoring the reverse is that the products decrease and then the reactants increase, all of the reactants. Another way of saying this is that the equilibrium will shift to the left. So if it's reverse, it's shifting to the left. If it's forward, it's shifting to the right. Okay? Alrighty, great. I'm trying to remember, we did not, for people that were not here last time, you guys hadn't done temperature yet, is that correct? Okay, so look at number 5, and actually at the bottom of page 29, down in the margin down here, we're going to draw this. So just a reminder, If I had that energy diagram from before and the reactants were higher energy and the products were lower energy. Okay, reactants, products. Okay, so there's my reactants, there's my products. This is an exothermic reaction. This is exothermic because to go from reactants to products, we lose heat. We decrease heat. So if this is going to show up in a chemical equation, we have reactants turn into products, but when they do that, they also released heat. Okay, they also lost heat when they did that. So endothermic is the opposite. When we have our energy diagram and reactants were lower energy and products were higher energy, reactants, products, it had to gain energy to get to the products. And so the way that that would look is you would have reactants, but we have to add heat before they turn into a product. Okay? Okay, so if you look at number 5, find heat. Is it on the reactant side or the product side? Product side. Does that mean that that reaction is endothermic or exothermic? Exothermic. On the quiz, you're going to have to identify this. So for the reaction on number 5, it was exothermic. Okay, the good news is now it's just the same as before. So what would happen if you add heat? Another way of saying this is increasing temperature. So what if we increase the temperature or we add heat? That's the stress. Okay, that's what we did. The reaction responds by trying to decrease heat. Okay? I hear my AP Chem students, they must be on their break. That's good news. They seem jovial. Good job sending them your good vibes. Thank you. Okay. So, if heat is a product, and see how the reaction responds by decreasing a product, is that a forward or a reverse reaction? Decreasing product. Reverse, exactly. So we're gonna favor the reverse. And as you favor the reverse, all of the products are going to decrease and all the reactants are going to increase. And then we could also say that our equilibrium had a shift to the left. Okay. Everyone, I want you to try number 6. I'm going to do it at the same time right now. Those of you that are watching the video, if you want to pause the video and give this a go, you can. Okay, those of you in the classroom, give that a go, and I'll do it at the same time. Number 6. Oh, and tell me if it's endothermic or exothermic as well. Okay, perfect. So I'm doing this video right now with this group. You're okay. And then as soon as I wrap that up, then you and I can look at that, okay? It'll probably just be a minute or 2 longer. No, yeah, you're good either. Okay, when you guys are ready, look at the board there and see how you did. Okay. There's lots of questions I could ask you on the quiz. So like on the quiz, I'll give you this reaction and then I would say, hey, if we increase the temperature, what happens to the amount of N2? And we'd say decrease. If I increase the temperature, what happens to O2? Decrease. If I increase the temperature, what happens to NO? Increase. Or I could have said, hey, if I increase the temperature, what reaction is favored, the forward or the reverse? And we'd say the forward. Or I can say, hey, if the temperature increases, which way does the equilibrium shift? To the right or to the left? And that would be to the right. Okay. All right. Everyone do one last one, and then I'm going to have to film another video, and I will email it to you all to show you the graphs, and then you should be ready to take the quiz. You might want to do a little practice on the worksheet there. So we're going to change number 7 really quick. So it says, what would happen if you remove some heat from the reaction? Change this to what stresses could be added to maximize or to produce O2. What stresses could be added to produce O2? Okay, that's a little bit different. So instead of me telling you what the stress is to make the reaction do a certain thing, I'm telling you what I want the reaction to do, and you're going to tell me what stress you could add to this. So what stresses could be added to produce O2? So we want the response by the reaction to be increasing O2. Okay, so we want that response to be increasing O2. O2 is on the reactant side, and so that would be a reverse reaction. Like, we want stresses that is going to cause the reaction to favor the reverse, where the products are going to go down and the reactants are going to go up. Okay. What stress could we do for the temperature or the heat? Do we want to, as a stress, increase heat or decrease heat? Increase, because that would be an arrow up, and then the reaction responds with an arrow down, right? So one stress would be increase heat. Okay. Another stress would be increase SO3. Increase the concentration of SO3 or the amount of SO3. And then I wouldn't worry about the opposite of what we're producing. Like, if we want to produce O2, I'm not going to want to do a stress of decreasing O2. Kind of defeats what I'm going after. But I can do this one. So what would the stress be that goes above SO2? Would it be increase or decrease? Decrease, exactly, because the reaction responds by increasing it. So the third and final stress would be decrease SO2. Okay, everyone, we've talked about everything we need to except for the graph. Like I said, I'm going to film another video on that. I will have the answer key up here, and I'm going to put it on the video right now in case anyone wants to pause. But before you do this quiz, it would be a good idea to do this worksheet that starts on page 31. Okay. And it ends at the end of the packet here, but I'm just going to put this on the video right now so people can pause and get those answers. The most important thing, though, if you have not finished the questions through 5, I would jump all the way to 6. I would start with 6, and then I would keep going until the end, okay? So almost done looking at these. I'll leave this at the front of the room for you guys so you can work on it if you want. For our last little bit here, here's that. And then this is the final one. Okay.